All right, everybody, here is the Unit 10 Function Operations Review. I'm going to go over this with the understanding that you have already completed the review on your own. So this is just to go over it quickly and make sure that you're getting the correct answers. If the pace is too slow for you, you can change the speed in your settings, right, to go faster. Feel free to pause or do whatever you need to do. Just make sure that you're understanding the content. So let's start with this first one. 5 times f of x plus h of x. So I'm going to take 5 times the expression f of x, 3x minus 11, and then plus the h of x expression, 6x squared minus x, maybe I need a copy of this with me, minus 77. That's going to do that. Sorry. Just one second. Okay, this will allow me to work through a little bit better. All right, so then I'm going to distribute this 5 through the first expression, so 15x minus 55. And then this parentheses after the plus sign doesn't really impact anything. So I'm just going to go and look for like terms that I can combine. So I have 6x squared, 15x and negative x, and negative 55 and negative 77. That's going to be, I think, negative 132 maybe. Let me check that. Yeah. Okay. So that should be it for number 1. Number 2, we're multiplying two functions together. So I'm going to take f of x, which is 3x minus 11, times g of x, which is 6x minus 7. So you've got 18x squared minus 21x minus 66x plus 77. Combine those like terms. And we should get that. Okay, number 3, 2 times g of x minus, and I think the parentheses are important on this one because we've got to distribute that negative to all of those terms, right? So we'll have 12x minus 14 minus 6x squared plus x plus 77, right? So I took that to get the 12x minus 14. Okay, now combine like terms. So we have negative 6x squared plus 13x. 77 minus 14 is going to leave us with positive 63. All right, number 4, we have h of x, 6x squared minus x minus 77, divided by f of x, 3x minus 11. If you've got a quadratic, it's a good idea to check and see if it factors. So this one, if you do a times c, you get quite a big number, 462. Because our b value is really small, what I recommend doing is taking the square root of 462, which is 21 point stuff. So I'm going to see if 22 times 21 yields what we need here. Those are 1 apart from each other, and then they multiply to give us that. I just checked. So if that one is negative, remember to divide by a, or 6. So 21 sixths becomes 7 halves. So that factor will look like 2x plus 7. And negative 22 sixths becomes negative 11 thirds. So that will look like 3x minus 11 divided by 3x minus 11. 3x minus 11 divided by 3x minus 11 equals 1. So we're left with 1 times 2x plus 7, or just plain 2x plus 7 on that one. Okay, number 5. If a of x, given a of x equals 4x plus 7, if a of x equals 23, find x. So these two things we're going to set equal to each other. They both equal a of x, so they have to equal each other. And then we can solve to find x. So we have 4x equals 16. Divide by 4. X has to be 4 in this case. number 6. Given that b of x is negative 4/5 x minus 4, and b of x is 6, we'll add 4 to both sides. So I get negative 4/5 x equals 10. I could divide both sides by negative 4/5. I could multiply by both sides by negative 5/4. I could start by multiplying by 5. That would give me negative 4x equals 50, and then divide by negative 4. Gosh, does 50 divide evenly by negative 4? I don't think so. Negative 25 halves, which is the same as negative 12.5, I think. 0.5. Okay. Here we go. 10 divided by negative 4/5. Yeah, okay. I think we're in good shape. Okay, looking over here at these, now we have compositions of functions, right? So I encourage you to definitely start with the inside expression first. G of x, this thing, x minus 4, that's what we're going to use everywhere there's an x in the f of x function. So I'm going to replace every x with g of x. So got that one done. And by g of x, I mean that expression. And then we're doing minus 5 times x minus 4, and then minus 11. Okay, so x minus 4 squared will become that. Negative 5x plus 20, and then minus 11. Looking for like terms. 36 minus 11, I think that's going to be plus 25. Okay, this is the same as the previous one, just different notation. So we are going to start with f of x, that's what we're using, and we'll replace every x in g with that. So f of x is x squared minus 5x minus 11, and I'm going to replace the x in g with that, so then it would just be not minus 4. Okay, so really these are the only like terms that's going to change anything. X squared minus 5x minus 15. Okay, this one we want to first find g of negative 2. So that's going to be negative 2 minus 4, that's going to be negative 6. So g of negative 2 is negative 6, so now we want to find f of negative 6. Okay, so what we were looking for is, what is f of g of negative 2? Since we know this is negative 6, I'm now going to replace it with that, right? So I'm replacing in the f function. Everywhere there's an x, I'll put negative 6. So we get 36 plus 30 minus 11. That's 66 minus 11. So we get 55. Excuse me, I don't know what's happening with my throat. Okay, find two functions, f of x and g of x, such that h of x equals the composition of f and g of x. I love these problems. So what we're going to do here, I think that on the handout it looks like that, right? We got a step function. What I'm going to do is look for a place that is like a good breaking point. So what I'm going to do is just take this expression, and I'm going to say that g of x equals 7x minus 2. And then f of x is going to look like that, except the yellow part that is 7x minus 2, in that yellow part, I'm just going to put an x in that place. So it will become 1/7 greatest integer of x. And then you could test it out, right? So find for yourself f of g of x and make sure that it leads back to this. So if we did, excuse me, we would start with g of x, which we said is 7x minus 2, and we're going to put that where the x is in that function, and we get back to our original, right? This isn't the only one that works here, but it's a sample answer that could work. I think it's a pretty good one. Okay, on this one, looking for another good break. I think I'll take that. So I'll say that g of x is equal to x plus 4. If you haven't solved these already, shoot, I wish I could go back and undo that now. Pause and try and figure it out on your own, right? That's what's really going to pay off, is you putting in some mental work to try and get this. Okay, so now if I took this and replaced the x with that, I would get back to my original, right? So that's what we're looking for there. Okay, again, just a sample answer. Okay, number 12, find the inverse of the following relations. So remember that you're going to replace this with y, then swap your x and y. So we've got x equals 1/2 y minus 7. I'll add 7 to both sides. Then multiply both sides by 2, or divide both sides by 1/2. It will yield the same results. We'll have 2x plus 7 equals y. 2x plus 14 is where we'll be. And then if we want to rewrite it in function notation, because this function was h, I'm just going to rewrite it with our h inverse. Okay, let's try 13. So we're replacing the g of x with y, then switch the x and y. So we'll have x equals 2y squared minus 5. Add 5 to both sides. Divide by 2. Take the square root. Okay, we want to rationalize the denominator to put it in simplest form, so I'm going to multiply the top and bottom by the square root of 2. So on the top we'll have the square root of 2x plus 10, and on the bottom we'll have just plain 2. And if I were to rewrite that in function form, that would have g inverse of x equals that. The inverse of g. I'm not sure the right way to say it. Okay, 14. Place this with y, swap them, so we have x equals 4y minus 3 all over 2y plus 5. Multiply both sides by the denominator, 2y plus 5. We get 2xy plus 5x equals 4y minus 3. I want all of the y's on one side of the equation and everything that doesn't have a y on the other side of the equation. So it'll look like 2x y minus 4y, right? I'm going to subtract that from both sides, and then minus 5x, subtract that from both sides and get minus 3. Factor out y. We want to isolate it. And divide both sides by 2x minus 4. And rewrite it in function notation. Okay. Replace the h of x with y. I have x equals 5/2 y plus 4. Subtract 4. Multiply by 2, maybe? Multiply both sides by 2. That would be 2 times that quantity, so let's go 2x minus 8. Divide by 5. Oh, and then let's go ahead and put that in function notation. Okay, 16. This would be y, and then swap. X equals 2 times the square root of y minus 1. Divide both sides by 2. Square both sides. And add 1. equals G inverse X. Okay, 17. That becomes y, so we have x equals 3y plus 2 all over 8y minus 3. We don't want a variable on the denominator, so I'll multiply both sides by 8y minus 3. Get rid of the fraction. Bring the the y's both over to one side, and everything else to the other side. Factor out the y. And divide both sides by 8x minus 3. Let's see, this is k. Inverse of x is 3x plus 2 over 8x minus 3. All right. Down here, we're evaluating. So I want to find the f function. Mine's color-coded. The f function is this one that's doing that snaky thing. So I'm going to go over to -7. That's right there. And that is at 0. The y value there is 0. H of 5. H is blue for me, so there's that. I go down 1, 2, 3, 4, 5, 6. So down at -6. G of 0. When G equals 0, this is down 2, so it's -2. G of 2 is 1, 2, 3, 4, -4. H of 2, oh no, H of 2 is 0. I was wondering if I tried that on the other. F of -5, there's -5, so 1, 2, 3, 4, 5, 6, 7, 8, 8, -8. Okay, f of -7, that's 0, minus g of -5, there's -5, so 1, 2, 3, that's 3. 0 minus 3 is -3. H of 3, I gotta clear out some of this stuff. H of 3 is 1, 2, 3, 4, -4, times g of -7. There's -7, 1, 2, 3, 4, 5. -4 times 5, that's going to be -20. And finally, we have f of -5. That's there, so 1, 2, 3, 4, 5, 6, 7, 8. -8 minus g of 0. That was -2. -8 minus -2 is the same as -8 plus 2, so we'll get -6 there. Okay, and then this newish concept. Given that this is true, f times, or composed with the inverse of f of x equals x. Determine whether the following functions are inverses. So what I'm going to do is plug one into the other. All right, so let's say that, well, let's put this in for that x. Okay, so we're going to say the third root of x plus 3 to the third minus 3. Our goal is to see if that equals x. That's what we want to have happen, so let's see if it does. The third root of something to the third power cancels each other out. So we have x plus 3 minus 3, and that 3 minus 3 is 0, so we just get x, so it worked. Yeah, that's all we need to do is show that. That one's good. Let's try 28. Okay, what if we put this whole thing in for that? So we'll say 4 minus 3 halves times, that's supposed to be a big old parentheses, 1/2 x plus 3 halves. So I need to distribute this -3 halves to everything. So that will be, I've got the 4 out there, -3/4 x minus 9/4. 4 minus 9/4. Let's see. 4 can have a denominator of 4 if I multiply the top and bottom by 4. So 16/4 minus 9/4. That's 7/4. So I'm getting 7/4 minus 3/4 x, and that's my end there. I'm not getting to x. So I'm going to say no, not inverses. If I'm not sure, I could also just try to find the inverse of this and see if I do end up with that, because if I do, then I've made a mistake here. So let me just test that real quick. I'll replace this with y, then swap them, right? So we get x equals 4 minus 3/2 y. We would subtract 4, multiply by 2, divide by negative 3. Yeah, this is not that, so I further agree that they're not inverses. Okay, 29. Let's go opposite this time. I'm going to take this guy and plug it in for that. So I'm going to go 4 times negative 4 plus 1/4 x plus 16 and see what we get. Don't even need equals there. So that's negative 16 plus x. 1/4 times 4 is 1 plus 16. Those two will cancel each other out, and we're just left with x. So yes, inverses. Okay, 29. Ooh, we have the same function. Okay, I'm going to take this and put it in there. So you have negative x plus 3 plus 3. So if we distribute, we get x minus 3 plus 3. That goes away, and we're just left with x. Cool. The functions are identical, but they're inverses. Neat. All right. Hopefully this was helpful to you. We will plan on the test tomorrow. So good luck, and feel free to email me if you have any questions or come in before school, but I would like to start the test right at the beginning of class. In the past, when we haven't done that, students have run out of time. So awesome. Good luck.